Hi third year, how you doing? Hope you're all okay. This video is going to be on the conservation of energy. So last week we looked at kinetic energy and potential energy. This week we're going to look at how they're linked together and the relationship between them, okay? So by the end of this lesson, if you can explain what is meant by the conservation of energy, and if you can carry out calculations involving potential and kinetic energy using the conservation of energy, then we've all had a good day. Okay, so let's define the conservation of energy. Energy cannot be created or destroyed, but it can be changed from one form into another. So in this case, potential energy to kinetic or kinetic to potential. When an object falls freely or moves down a slope, the potential energy at the top is equal to the kinetic energy at the bottom. So this is a key phrase. The potential energy at the top is equal to the kinetic energy at the bottom. So that will be very important when you come to do the worked example. So let's look at this. A 1,000 kilogram vehicle is at the top of a slope when the handbrake is released and the car rolls freely down the hill. Calculate the speed of the car at the bottom of the hill. Assume the surface is frictionless. So before you pause the video, I just want you to look. We've got the mass, we've got the height, okay? So that's the only two pieces of information that we have, and we're asked to work out the velocity. So it seems really, really difficult, but if you just keep in mind the conservation of energy, then you can work it out, okay? So pause the video and have a wee attempt at it, and we'll come back and we'll do the solution together. Hi there, welcome back. So first things first, always get your data list down. So the mass equals 1,000. The gravitational field strength is, we know is 9.8, but for this question, we're just going to take it as 10. And we've got the height, which is 10 as well. And we're asked to calculate the velocity. So there is no formula that can link all these together to give us velocity, but we know that potential energy equals mgh, okay? So let's work out the potential energy of this car at the top. So EP equals mgh, that equals 1,000 times 10 times 10, and that equals 100,000 joules. So we've now got the potential energy at this point. But the conservation of energy tells us that the potential energy here equals the kinetic energy at the bottom. And we can use that little key to open up how to do the velocity, okay? So the potential energy here equals kinetic energy here. And that allows us to use EK equals a half mv squared, where our EK is our EP value, 100,000, equals a half times 1,000, which is our mass, times v squared. And just like the last video, we rearrange that for v squared. It gives us v squared equals 2 times 100,000 divided by 1,000. But remember the added little step, this is v squared, so we need to square root both sides to get v. So v equals the square root of 200, which equals 14.14 meters per second. So well done if you got that right. So hopefully now you can understand the conservation of energy. The potential energy at the top is equal to the kinetic energy at the bottom because that energy has been transferred from one form to another. And if you get any questions, please just let us know, and we will see you next time. Thank you very much. Bye.